Learn about graphing sine and cosine functions, and we're going to learn about translating them. We're going to talk about shifting them left, right, up, down, and stretching them and compressing them. So first let's start with the sine function. You're going to see a correlation between these two. So y equals the sine of x. Note that this is a hard lesson, and it may be very possible that you will need to go back and watch this video a couple times just to understand. So y equals the sine of x. So a basic sine and cosine function is broken into 4 parts. Every single time it's broken into 4 parts. Now how far those parts are evenly distributed depends on the function, whether it's been stretched, compressed, moved left, right, all those kind of things. But this is a basic sine function. We're going to make 4 sections. So there's 1 section, 2 section, 3 sections, and 4. 1, 2, 3, and 4. So basically it starts here and it ends here. Now sine and cosine functions have no basic starting point and no ending point, which means they keep going to the left on the graph and to the right, there's no stopping it. All right, so if you can do me a favor, I'm going to tell you that this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Grab that unit circle that's in front of you, please. Grab a unit circle that's in front of you, and put your finger on 0. Put your finger right now on 0 on your unit circle. Now at 0, there is an ordered pair. It consists of a cosine and then of a sine. Alma, if you do not have one, you need to sit next to somebody or you're going to be lost today, okay? Consists of a cosine and of a sine. What is the sine value at 0? You're not looking up here, you're looking on your paper. 0. So here we go. Along the y-axis, we're at 0. Now put your finger at pi over 2. Put your finger at pi over 2. What is the sine value at pi over 2? So we're going to go up 1 unit, go over to pi over 2, and up 1 unit, and make a dot. Yes?
Could you please make it darker?
Sure. Let's see if I can. You may have to sit a little closer. I don't think I have the ability just to make this darker. I'm sorry. Okay, put your finger on pi. What is the sine value at pi? So let me see if I have a small, because I feel like there's quite a few that you are feeling confused. So I gave away all of my pre-made ones already. Do you agree at 0, the sine value is 0? So at 0, I graph a y value of 0. Remember, y values are really like you're going vertically on the sine axis. And then at pi over 2, you have a y value of 1. So go over to pi over 2 and up to 1. Now go to pi. What is the sine value at pi? 0. So go to 0. At 3 pi over 2, what is the sine value? So go down to -1 and go over to 3 pi over 2 and down to -1. And then now go back to 2 pi, and what is the sine value? Okay, if you recall, I said whether we use positive or negative coterminal angles, is there any limitations how many times you can go around this? So there's no limitations how far. So look how this is. If I break this into 4 so that you can see it, do you see how I chose 4 equal parts? So there's up 90, up 90, up 90, up 90, all the way around. They're exactly equal. I could keep going, which means, guess what? The next one, if I make an equal distance, the next one would be up, and then what would it be after that? Down, and then it would be down, and then it would be over, right? Do you see how it just keeps going? It's often referred to as like a wave. So it starts here, and now here's the deal. This is not a V. It has to make a curve. So it hits the top part of the curve here, and then it rolls down through the x-axis, hits the bottom part of the curve, and then rolls back up. It does the same thing going in the opposite direction. Okay, grab your calculator and do second plus 712, please. Second plus 712. And I want you to go to y equals. I want you to go to y equals, and I want you to type in the sine of x. Please ask other people what you need to do. You need to have a couple different things at your desk. And I want you to hit graph. here is our origin. I'm going to refer to this as a hill, and I'm going to refer to this as a valley. So here's your hill, here's your valley, and it continues to go. Hill, valley, hill, valley. Hill, valley, hill, valley. This is on a sine curve that has not been changed at all. Okay, we're going to leave this here, and now we're going to do y equals cosine. Grab your unit circle. Starting at 0, what is the cosine at 0? 1, so go up 1 and make a dot. And at pi over 2, the cosine is 0. And at pi, the cosine is -1. And at 3 pi over 2, the cosine is 0. And at 2 pi, it's back to 1. Remember, do not make sharp points here. This is not a V. This is curved. So it hits your top part of the curve and comes down, comes back, hits your top part and goes back down again. Now, although these look different, the sine and the cosine curve are actually the same curve if we could just translate it. So do you see how the cosine starts at a hill? Starts at a hill, then what does it do? A valley, and then what does it do again? A hill. Well, go back to sine. What does sine start on? It goes hill and then valley, right? Sorry, it goes hill, full hill, and then valley. Well, this just starts at the top of the hill. So if I could translate this, they actually would look alike. Okay, those are the basics. What I need you to do is on your desk, I need you to think of your desk as this entire white piece of paper. And look up here right now. We got to move fast today, okay? So this is your entire desk. I want only the very top, just a small portion of the top on your desk. One side to be the sine, one side to be the cosine. You have exactly 2 minutes to get that done. Go. You're down to minute 45 to have them both graphed on your desk. One minute remaining. We are going to get started. So, April, you need to quietly ask somebody else what you all need to get done right now, okay? Okay, so we're going to start with this one. What I'd like you to do is to make another graph and label it. And now the difference between what you see up above. By the way, Rodrigo, I'll start using pen and tell me if that makes a little bit of a difference, okay, sir? The difference from what you see up above and this is now we have this 3 in front and we have a -2. Now, what you've learned about functions is if there's a number hanging out in back and it's separated or in front and it's separated. This is not separated. -2 plus this would be separated. This number that's hanging out in back that's separated would be referred to as a vertical shift. So we're going to shift the entire graph down 2 units. The number in front, do you recall where we talked about stretches and compression? If something is stretched, it'd be like taking this, and do not do this to your graph, but if something is stretched, it would look like this. It's going to go up higher, and it's going to go down further. That would be stretched. That's when the number in front is greater than 1. The larger the number, the greater the stretch. If something is compressed, it would be flatter. Now sometimes students say, but what if it's negative? Who recalls if it's negative? What does that mean? Reflection across the x-axis. So there's not a reflection here, but there is a stretch. So this is a stretch by 3 units. Okay, so this is what we have. And here's how I graph this. We're going to go down 2 units. So we're going to extend this down, and we're going to go down 2 units, and I'm going to mark it off as -2. And I'm going to take a dotted line, and I'm going to go through here. I'm now going to pretend like that is my new x-axis. That's what you guys would have referred to this before as an x-axis, okay? That's what I'm going to think of this as. All right, so when I look up above, I can see that there is no shifting to the left or right. That's going to occur with the x. There'd be parentheses around this. You'll see that in an upcoming problem. So for this, I get to go up above and go, okay, remember, look at the unit circle. Let's practice again. Look at your unit circle. Put your finger at 0. What do you have for an answer? Does everybody agree with 0? Okay, watch this. Think of this as the origin. This is your 0 line. Forget about this line now, okay? Think of this as your origin. So you told me the answer is 0. What's 0 times 3? So right here, 0 times 3 is 0. Now go to pi over 2. Put your finger at pi over 2. What is the sign at pi over 2? 1 times this 3 is, okay, so go here. Don't do anything yet. We need to go 3 above, not just 1 above like normal. We need to go 3 above because it's stretched. So there's 1 unit above, 2 units above, 3 units above. Put your finger at pi. What is the number? A little bit louder for me, please. 0. 0 times 3 is 0. Put your finger at pi, 3 pi over 2. 3 pi over 2 has a sine value of -1 times 3 is, so we're going to start here, we're going to go 3 down. 1, 2, 3. Put your finger at 2 pi, please. 2 pi is 0, and 0 times 3 is 0. Make sure to include arrows on both sides. Remember that this is an ongoing curve. The number 3, which we refer to as a stretch, you're writing this in your notes, is called the amplitude. Please write that down. The number in front of the function is referred to as the amplitude. And an amplitude describes how far away from the midline, write the word midline. How far away from the midline you're going to go. So this extends 3 units away from the midline, a maximum of 3 units away. Now let's look over here. Come up here. Let's look at this original one you have on your paper. The midline here is right here. This is your midline. What is the maximum distance here? How many units? 1. How many units here? We only say distance in terms of positive numbers. So this is a distance of 1. This is a distance of 1. So this has an amplitude of 1 unit. Now, how can you look at an equation and tell that? Whatever number is directly in front of the function, so in front of the word sine, cosine, tangent, that will always tell you the amplitude. Amplitude of, we don't see a number, it's a hidden 1. Now we see a number, it's a 3. So it's an amplitude of 3. Now I want you to turn to your partner. If I did this, talk to your partner, and just, I want you not to erase anything. I want you to add to your graph that you just did, the same graph. What would this look like if I did this? Okay, talk to your partner. You have 30 seconds to change. Ready, get set, go. Okay, thank you. All right, so if we were going to do that, and I'm going to change colors here, I would start here, but instead of going up 3, I'm going to go down 3. Instead of going down 3, I'm going to go up 3. Please don't talk when I'm talking. Remember that these are curves. These are not sharp V's. How many of you have this? Something similar to this? Hands up high. Okay, so we're going to have you, before I go on to cosine, let's just practice one more and see how you can do with this. This time, I'm going to be based on your knowledge. Please erase on your desk just only the last problem you did. Erase only the last problem you did. Go. On your desk, erase the last one you did if you have not done so. So if you're still confused, please take this entire thing and erase this. Here's the problem. With your partner, I'm going to give you a chance to draw this. With your partner talking the entire time, you're going to have 1 minute to do that. No calculator work. No calculator work, Brian. Okay, on your marks, get set, go. Yeah. 30 seconds remaining. Down to 15. Okay, and stop. Done or not done? Please, eyes up here at this time. Here's how I'm going to start you. So the only things I've taught you to this point are these two, and I'm basing your understanding of functions on this first one. So we would call this a vertical shift. So we're going to go up 1. Please make a dotted line here. Now on the last problem, I refer to this as the midline. Please write that down on your desk, midline. The midline requires an equation. So this is a horizontal line. It cuts through the y-axis, and every point along this line has a y value of 1. This is required. Has a midline of 1. Where do I get that from? It comes right from your vertical shift. Second, I'd like you to put your finger on your circle, on your unit circle. Please start at 0. What is the number for 0? What is the sign of 0? It is 0. So 0 times 2, 0 times 2 is still 0. Remember, this is like my new x-axis, so put a little dot here. Please go to pi over 2. What is the value of the sine? 1, right? Okay, well 1 times negative 2 is negative 2. So I'm going to go down 2. There's 1 and 2. And this causes that reflection. It's going backwards. Put your finger at pi. You get a sign of 0. 0 times negative 2 is 0. At 3 pi over 2, it should be an answer of negative 1. But negative 2 times negative 1 is positive 2. So up 2 more. Here's 1, 2, 3. Back to 2 pi. So at 2 pi, the sine value is 0. 0 times negative 2 is 0. So I'm going to come down, make sure that it's not a V, that it is a curve, and you have arrows at both ends. Going to review what you need to know at this point. You need to understand that this is a vertical shift. The vertical shift determines your midline. You have to be able to come up with that equation. This is called the, please repeat the word, what's the word? It is amplitude. And it describes the distance from the midline. This describes distance from midline. Remember, distance is always a positive number. And out front, we have a reflection across the x-axis. Okay, now a new concept. So do not draw this, but this is a wave that's going to keep going, right? Yes? This wave is consisted of 2 things. I'm going to use the term a valley for this, and then a valley and a hill. That's one wave. And you're taking this thing, and it's like a computer. You're going to copy and paste it together. Copy and paste and link them together. But one of these parts of a wave is a valley and then a hill when I use this function up above. Okay? This is called the period length. Some books just call it period. Some books call it period length. It means the same thing. You should write it down. Period length means how many units does it take to do one complete revolution around the unit circle. In our case right now, it is pi over 2. Now I'm going to describe how to get that answer by just simply looking up above. Okay, so define the period length. And again, sometimes it's just called period. Define the period length, and that's the length of one cycle here. You're going to take 2 pi, and you're going to divide it by whatever is in front of the x. Well, what number's in front of the x? What number's hidden right there? A 1. 2 pi divided by 1 is, and how far is this? It is 2 pi. Later on, we're going to do problems that are further along. Okay, let's do the next one together. We'll stick with sine for one more time.
You just added in, why'd you put the 2 pi came from like the line, right?
2 pi represents one revolution around the circle, and we can use that to figure out how long that curve will take. Like we're going to do a problem now that it takes more than 2 pi to do it. Okay? So write down y equals negative 3 sine of 1/2 x plus 4. So this time I want you to make 4 lines here, but I do not want you to label them yet. Just make 4 lines. It will always be 4 sections. Always be 4 sections to complete a sine or a cosine. The first thing we're going to do is we're going to figure out the period length. Remember, some people just call it the period. So period and period length are interchangeable terms. To do that, I want you to write down 2 pi divided by 1/2. Now, leave the pi symbol there. Either do it in your head or grab a calculator and go 2 divided by 0.5. If you take 2 divided by 1/2 and you use the fraction, you need to put the fraction in parentheses. Can anybody tell me what you end up with? A little bit louder, please. 4 pi. For some of those that are a little lost right now, if I take 2 and divide it by 0.5, I end up with 4. Okay, that means the very end of one cycle is 4 pi. Now, if we have to cut 4 pi into 4 equal parts, it's pretty easy. Take 4 pi and divide it by 2 to get the middle, which would be 2 pi. 2 pi divided by 2 would be 1 pi. And what's between 2 pi and 4 pi? 3 pi. That's a very easy one. So the first thing I did, I'm going to make a little list here. The first thing I did was the period length. The second thing I did is I labeled the axis. Okay, your third thing is going to be the shift, vertical shift. So what is the vertical shift for this particular function, Roger? So everybody go up 4. 1, 2, 3, 4. Make a dotted line. And we have to label the midline. This midline has all y values of y equals 4. Okay, put your finger back at 0, please, on the unit circle. We are now going to take the amplitude and we're going to apply the reflection using our unit circle. So on the unit circle, put your finger at 0. What is the sine value?
0.
What's 0 times negative 3?
0.
Dot here. Okay, now there's a couple ways to do this. I want to show you one way. I want you to put your finger right now on pi. Put your finger on pi. So we're going to test this out. Okay, where's your unit circle right now, Martine? Okay, what is the sine value of pi? 0 again, right? So watch how this would not work. Now put your finger on 2 pi. Okay, on 2 pi, what is it? 0. So how could we get a function if we just kept doing that? Okay, does that make sense to you? That'd be difficult. So I still want you to think of it in terms of what I would refer to as the north, east, west, and south. So we're going to start again. Put your finger right now at 0. Okay, and at 0, please tell me what is the sine value. Once again, it is 0. Now put your finger at pi over 2. Sine value is 1, right? 1 times negative 3 is? So from here down 3. 1, 2, 3. Finger on, not 2 pi, put your finger on pi. Because we're going to go in each one of those quarters. On pi, what is the sine value? 0 times negative 3 is? Finger on 3 pi over 2. Sine value is? Negative 1 times negative 3 is? Positive 3. So you need to go 3 up. 5, 6, 7. And put your finger on 2 pi. The sine value is 0. If somebody said, what is the amplitude? If you said negative 3, you're wrong. The amplitude is simply just 3. The negative sign represents the reflection across the x-axis. So if I look at this and I analyze this, reflection across the x-axis, okay, I've done that. Amplitude of 3, so a distance of 3 as the maximum value to go back to what we call the midline, got it. We have a period length of 4 pi, and we have a vertical shift of 4. Next problem is with your partner. Okay, so erase that last problem, please. Okay, with your partner, here's the problem. And with your partner, I'm going to time you. You have 3 minutes. Okay, follow the steps we did before. Again, these are the steps we started with. Follow these steps, and here's the problem. Go ahead. So here you're talking with your partner. 2 minutes remaining.
So the first one's 0. First one is 2. They go up 2. And then first over.
No, but right, look at it from here.
6. No.
Keep going. Like following the people.
Down here. And then 8. It's going to be 0. Yes.
So what?
Very good conversation. For time reasons, I'm going to stop you. For time reasons, everybody can look here. Let's first figure out the period length. So write 2 pi divided by 1/4. What is 2 pi divided by 1/4?
8.
So write 8 pi. What's half of 8 pi?
4 pi.
4 pi. Half of 4 pi is 2 pi. So I'm going to go by 2's, and that makes this 6 pi. Can you just by raise your hands if you labeled this correctly? Great job. Okay, then I'm going to do the next thing is I'm going to look at the shift. I'm going to go down 3. So 1, 2, 3, make a dotted line. This is y equals -3. Hands up high if you got that far, at least. Okay, good. Okay, the next thing is, so I've labeled the midline. I've done that. Now I'm going to use this point. So I start here, right? So we all know that we start here for sine. So at 0, the sign is 0. 0 times 2 is 0. Then go to pi over 2. At pi over 2, the sign is 1. 1 times 2 is 2. So from this line, go up 2. 1, 2. Then I'm going to go to pi. The sign is 0. So 0 times 2 is 0. Then I'm going to go to 3 pi over 2. At 3 pi over 2, the sign is -1. -1 times 2 is -2. 1, 2. And then back here. So it looks like that. Did anybody get that far? 3, 4, 5 of us? Better question. On a scale from 1 to 5, how comfortable do you feel with what I just did? 1 to 5, hands up high. Okay, the only thing we're going to change now, when I see you on Friday, we're going to change this part of it. We're going to shift it left to right. At this time, we're going to do cosines. So erase everything that's sine related on your paper. Go, everything that's sine related.
Original sine formula?
What'd you say, dear?
Even the original sine formula?
Yeah, we're only going to do cosine right now. Y equals, here we go. Y equals 3 cosine of 0.5 or 1/2 x minus 4. So start by making your line. Make 4. Then decide what would be the period length. Can anybody share with me what would be the period length? What'd you say? 4 pi, good. So put 4 pi down. And then label the other 3, which would be 3 pi, 2 pi, 1 pi. Four pi, 3 pi, 2 pi, 1 pi. Okay, so then I need to do, so I've take care of that, so I'm done with this. Then I'm going to do the vertical shift, midline of -4. Y equals -4. So I've taken care of that. Now I'm going to apply the amplitude. So start right now at 0. What is the cosine at 0? 1. 1 times 3 is 3 up from this point. 1, 2, 3. Now go to pi over 2. At pi over 2, What is the cosine? 0 times 3 is 0. Go to pi. What is the cosine? Negative 1 times 3 is negative 3. 1, 2, 3. Go to 3 pi over 2. Cosine. And go to 2 pi. 1 times 3 is 3. Remember, this is not a V. This is a curve. Arrows at both ends. 1 to 5 right now. How well do you understand that one? 1, bless you. 1 to 5. Take out the papers that you have right now, and we're going to write class notes on it. Please go to the first one. Write down y equals negative 2, bless you, sine of 1/8 x plus 1. Now down below, does everybody see these that are already been set? Yes or no? You are going to change those. So if you think that 4 pi belongs here, you change it to 4 pi. If you think this should be 2 pi, you change it. Does that make sense to you?
Yes.
So make these little lines here so you know, and then you're just going to change them. Okay, I'm going to have you circle what you need to fill out. So you're going to fill out part A. You're going to fill out part B. You're going to fill out C, D. You will not fill out E. Do not. So put a little check mark. We'll come back to that later. I want you to circle the word graph, but do not worry about this interval because you're changing that interval because you're going to change this according to what the equation I put down. Okay? I want you to try I and try J. Okay? So only the ones you've circled. Now go to the next one. I want you to do 4 cosine of x plus 1. 4 cosine of x plus 1, I want you to circle the exact same things. Circle the exact same things. You actually can circle E this time. Circle E as well. Let's see if you can have those done in 9 minutes before you leave with the help of your partner. Ready? Begin. Hey guys, I changed a little bit the requirements of the quiz. Please listen. You're going to repeat these to your partner to make sure that you are listening, you understand. So the quiz that you were given yesterday, listen closely. You have Tuesday, Thursday, and Friday. Tuesday, Thursday, and Friday to work on it in here during advisory. If you come during advisory, though, what I've changed is that you have to work by yourself so you can use notes. No phone. By yourself so you can use notes. In class on Wednesday, you get to use the help of your partner. So what if you're not here because you're taking an AP test? So then you don't have that opportunity in class, but you still have Thursday and Friday to work on it during advisory. Does that make sense to you? Yes, yes? Okay, go back to work.
Today, Thursday and Friday, or just Thursday and Friday?
No, today, Thursday, and Friday. Yep.